Lesson 4.3b, solve two-step equations. To solve two-step equations, undo the addition or subtraction first, then undo the multiplication or division. So we have solved equations doing one step this week. We did them separately. Now they're combining those two things together to create a two-step equation. So if you look at this first example that they did, it shows 7v minus 3 equals 25. You always go to the side with the variable and make sure the variable stays put. The variable could be on the left or it could be on the right. It doesn't matter. Whatever other number is with that variable, it's a number by itself, it's a constant, you're going to undo that first. So if it says minus 3, then you show that you add 3 to both sides. To keep the equation balanced, you have to show the same thing on both sides. And just like the one step, I need to see all these steps written out. You draw a line, and below the line, it's really important that you bring down everything you have. 7v equals sign 28. I've had kids in the past, they forget that equal sign, and then they're totally messed up. And that's a really simple thing. You wouldn't think it would mess them up, but once they write it and there's no equal sign, then they're thinking, oh my gosh, now what do I do? So after you have 7v equals 28, then it's the one step where you get rid of the number with your variable. So if it's 7 times v, you end up dividing both sides by 7. So we're undoing two steps. Let's go look at the problems that you guys have written down at the bottom. You were supposed to write down the odd problems. Okay, I don't think we're going to end up doing all these, but we're going to do a few. So let's look at number 1. Number 1 says 4y plus 1 equals 13. So I go to the side of the equation with my variable. Who wants to try to do this? Okay, Andrew, which side has my variable?
Left.
The left, because there's 4y. What number's over there without a variable that's on the left?
1.
So how do I make 1 go to the other side?
You can add 1.
Well, there's already a plus 1 there.
Oh, you
Remember? Take away 1. So we're going to subtract 1 here and subtract 1 here. And then you're going to draw a line. I want everybody to write the same exact thing as I just did. That is how you show your work. Subtract 1, subtract 1. And then, Andrew, you mark these two out. Now, what am I going to bring down below the line?
12 and 3. I mean, 12.
Start from the left.
4y.
4y
And 12.
equals sign and 12. 4y equals 12. Now, it's 4 times y. Andrew, what am I going to do? So to undo 4 times, we divide both sides, and you show that by drawing these little lines under each side and divide by what?
1.
What number do you want to go away?
4.
4. So then 4 divided by 4 cancels,
Yeah.
and y equals what?
3.
3. Good job. All right, number 3. Number 3. Caden, which side is my variable on?
Right.
The right. It's 5k. So what number am I going to move? Nope.
Oh, wait. 5.
What number's with my k?
5.
What number is with my 5k?
7.
7. The 7's got to go away. 7's the constant. It's got to go away. So how do I make plus 7 go to the other side, Caden?
You do -7.
Minus 7. Minus 7 on each side. Draw your line, and these mark out. Now, Caden, what am I going to bring down below the line? I have negative 3, but I'm losing 7 more. I'm in the hole 3, and now I owe or go back 7 more. Negative 10 equals 5K. Now, I want K alone. How do I get rid of that 5, Caden? Divide both sides by 5. So K equals what?
2.
Close. It's a negative divided by a positive.
Oh. -2?
Negative 2. Negative 2. Okay, those are very basic problems. Any questions about that? We're going to try a few more. We're going to try a few more. Question, or want to do the next one?
Kind of a question.
Okay, what's your question?
So, like like for example, the 7, you just like make it the opposite. So you just make it, if it's a positive, it's a negative.
Yes. You always undo what's there or do the opposite of what you see. Absolutely. Yep. If it's a plus 7, you subtract it. If it's a minus 7, you add it. All right. Any other questions on those two examples? Let's look at number 5. Number 5. It says 7 equals negative 3c minus 2. Dylan, which side's my variable on?
The left side. Or the right side.
The right side, because it's negative 3c, right?
Yeah.
So what constants on the same side as negative 3c? What other numbers there?
2.
The 2, the negative 2. How do I make that minus 2 or negative 2 go to the left? What do I do?
You have to do plus 2.
Plus 2 here and here. Okay, so these cross out. Now what am I going to bring down below the line, Dylan?
9.
9.
9 equals negative 3c.
9 equals negative 3c. Okay, I want c alone. How do I get rid of that negative 3?
Negative 3 divided by 3.
So I'm going to...
9 divided by 3.
Okay, now just be careful. It's a negative 3c. So you need to divide by what?
Negative 3.
Negative 3. Yeah, be careful with your signs. So those two cancel, and what would c equal, Dylan?
C equals negative 3.
Negative 3. Questions about that? Okay, I want to do number 7. Anybody want to try 7? Okay. Caden, which side's my variable on?
Right.
Right, it's right here. So what number is on the same side as negative 5t?
Negative 5.
Another negative 5. How do I take that to the other side?
Plus 1.
Yeah, I'm going to add 5, and I'm going to add 5. Now, look what happens. Over here, it definitely cancels out. What am I going to bring down below the line, Caden? What's negative 5 right here? What's negative 5 plus 5?
0.
Yeah, it's 0. So 0 equals
Negative 5.
negative 5t. And how do I get t alone?
Divide by 1.
I got to divide both sides by what?
Negative 5.
Negative 5. So that cancels out, and t equals. Now, Caden, what's 0 divided by anything? And 0 is definitely a number that can be an answer. 0 works. Questions about any of that? Okay, I am now going to skip down to, well, questions on 5 or 7. All right, it's time to do one like number 9. Here we go. It's combining what we did earlier in the week and then what we did yesterday. So number 9, 11 plus 7/9 n equals 4. Anybody want to try this one? Have you done one?
No.
Okay, so which side is my variable on?
Right.
On number 9?
9, yeah.
Of the which side of the equal sign?
Of the, oh, left.
Left. Okay. It's on the left, so it's right here. So that means my constant, my plain number's got to go to the right. What plain number do I need to take over there?
11.
And how do I make an 11 go over to the right?
11 minus negative 11.
How about just minus 11? Not minus a negative,
Oh, yeah.
because that would be a plus. Okay, so these cancel out. Now, Caden, what do I have next? What's going to come below the line?
7/9 n
7/9 n equals how much?
equals 4 minus 11.
4 minus 11, which is, I have 4, but I'm losing 11.
Which would be
I have $4. I have $4,
yeah,
but I owe
11.
11.
So
So you have $4,
yeah,
and you owe her $11. So you're going to give her the $4,
yeah.
and then you're going to tell her, I owe you,
Oh, $6. Negative 6.
close, 4 and then 11.
7.
Right, so you owe her 7, so negative 7. Now, Caden, there is a fraction in front of that n.
Yeah.
Yesterday we looked at some of those. What can I do to make 7/9 go away?
Divided by 7/9.
Okay, or multiply by, what's that called?
Multiply by,
Multiply both sides by, what'd we do with those fractions?
what?
We flipped them over, that was called the reciprocal or the multiplicative inverse.
Yeah.
So I'm going to multiply both sides by what?
Both sides by, what?
If I take 7/9 and I need the reciprocal,
Yeah, so
what would that be?
multiply both sides by 7.
So 7/9, the reciprocal, you flip it over, so what would that be?
It'll be 9/7.
9/7.
I got,
Are you forgetting what we did yesterday?
no, I just got confused.
Okay, so you cancel, and you've got n. Now I'm going to put this negative 7 over 1. Does anything cancel? I've got negative 7 over 1 times 9 over 7. Anything cancel from top to bottom?
The 7s,
The 7s both become what?
both become a 1.
Okay. So I've got a negative times a positive.
A negative times a positive is, it's going to be, a 1. I mean, a 9.
But it's a negative times a positive.
So it's a negative.
Negative, and then you're right about the 1 times the 9. So it's negative 9. A lot to think about on those, isn't there? Okay.